Okay, let's take a look at number 3 on Unit 5, Day 5 notes, just continuing from the last video. We're now going to graph the function y equals negative square root of x plus 3 minus 4. So, what do we notice about this one that's different? Well, this one has a negative sitting right out front of the radical. And that changes a lot of things. That changes the way the graph looks completely. It changes the way that we analyze the graph. So we really got to pay attention to this negative, and we're going to take care of it first. The negative tells us that we need to be reflecting over the x-axis, which is right here. We're reflecting over this axis. So we're going to reflect our parent graph, y equals x, over the x-axis. That's going to be the first step that we do, okay? So let's go ahead and do that. That means that this point will then correspond to this point. This point, which is 4, 2, will correspond to 4, negative 2. And this point, which is 9, 3, will correspond to 9, negative 3. And of course, 0, 0 just stays the same. So that is my new reflected graph. But we're not done yet. So all we've done is just taken care of that negative right there. We need to now look at our shift. What is our vertical shift and our horizontal shift? Well, what's inside of here tells me what my horizontal shift is. So, if I set x plus 3 equal to 0, I get that x equals negative 3. So that is the coordinate, the x coordinate of my new starting point, negative 3. And this guy right here tells me my up or down movement. Since it's negative, I know I'm going down 4, so negative 4 is the y coordinate of my new starting point. 4. So let's go ahead and make that new starting point. So I'm going to make the final graph in blue. I'm moving my original starting point, which was right here, to this new ordered pair, or this new point. So let's find negative 3, negative 4. It's 1, 2, 3, 1, 2, 3, 4. It's right there, okay? Then all the points are going to correspond to this graph right here. All the points on our new and final graph are going to correspond to those points. So I know that when I go to the right one, I'm going to go down 1. When I go to the right from my new starting point 4, 1, 2, 3, 4, I'm going to go down 2 from my new starting point. 2. When I go to the right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to go down 3 from my new starting point. So my new reflected graph, my reflected and shifted graph looks just like that. Okay? The reason why I chose to go to the right, the reason why I chose to go to the right 4 was because 4 is a perfect square. The reason why I chose to go to the right 1 is because 1 is a perfect square, and the reason why I chose to go to the right 9 is obviously because 9 is a perfect square. And so my y values were then just what they are, what those numbers are plugged into the function. So you can always check that with the little points chart that we have on the left of the graphs, if you want to make sure that you have the right points. But you're just transforming the graph, so these are the right points. Let's analyze the graph, okay? I'm going to write in red for my analysis. What is our starting point? Well, this is our starting point, and we said that it was this guy right here. Negative 3, negative 4. Are there any zeros? There are no zeros because our graph is never intersecting the x-axis. Our domain. it looks like the graph is defined everywhere that x is greater than or equal to -3. So my domain is going to be -3 to infinity. My range, well, x is defined everywhere that, y is defined everywhere when it is less than -4. So the graph is defined when y is less than -4. So my range will be from -infinity all the way to -4, including -4 because, including -4 because it's still defined when y is -4. My interval of increase. Is the graph ever increasing? No, that should be your answer. It's never increasing. It looks like now that we've reflected it, it's slowly decreasing. Our interval of decrease is going to be similar to that of our domain. It is decreasing from -3 to infinity. When we say our interval of decrease, we're talking about the x-axis. Okay? I want you to tell me an interval on the x-axis where it's decreasing. And our in behavior, okay, what's happening as x approaches infinity? What's happening now as x approaches infinity? Well, as I keep on going to the right farther and farther and farther, my graph is only, I know it looks like it's an asymptote, I shouldn't do that. Let me go down a little farther. As I keep on going to the right farther and farther and farther, the graph is just going to keep decreasing. Okay? It's decreasing very, very slowly, but it will be decreasing. So your answer for that is going to be as x approaches infinity, as we keep going to the right, y approaches -infinity. Because we just keep on getting lower and lower and lower on the graph. It goes down this way, which is -infinity. And so we finished analyzing this graph, and now we can move on to maybe some more.